Hello, welcome to Guidance Education channel. This is a channel for plus 1 that is class 11 and plus 2 that is class 12 physics and chemistry. Videos are uploaded in chapter wise playlist for the respective class and subject. Visit the channel, go to playlist and select the desired playlist. Please watch the videos completely so that you get all points cleared. And if you think the video is useful, do like the video and give me your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and support me. And also press the bell button so that you get intimated as soon as new videos are posted. Thank you very much. In this video, we are continuing class 11 chemistry chapter 2, structure of atom. Under that we are doing quantum mechanical model, and let us see the topic that is discussed in this video. The topic discussed is filling of electrons in orbitals applying aufbau principle, Pauli's exclusion principle and Hund's rule. This is part 12 under quantum mechanical model of atom. Okay, let us start the topic. Filling of orbitals of a few atoms. I have prepared a representation here. Let us see the details. This is the subshell electron configuration of the first 5 elements. And on the other side, I have given orbital picture diagram. The orbitals are shown as squares. The arrows in opposite direction are the electrons having opposite spin. Yes, subshell has only one orbital, so there is only one square. P has 3 orbitals. That is what is shown here. Hydrogen and helium belong to first period. Lithium, beryllium and boron belong to second period. There are 2 shells in second period elements, and principal quantum number 2 has 2 subshells S and P. I hope you remember those details. Hydrogen has 1 electron. It is in 1 S. That is what is shown here. It is unpaired. Helium has 2 electrons. Atomic number is 2. 1s electron is paired here. That is what is shown here. For lithium, there are 3 electrons. As per Pauli exclusion principle, an orbital can have only a maximum of 2 electrons. So 1s is fully filled. So the third electron moves to 2s. It has unpaired electron. 2s1 is unpaired. P orbitals are vacant, they are not occupied. For beryllium, atomic number is 4. So it is 1s2, 2s2. Both orbitals have paired electrons. Wherever there is pairing, you find that they are represented in opposite directions, representing clockwise and anti-clockwise spin. Boron, atomic number is 5. 1s2, 2s2 and 2p1. As per aufbau principle, the next higher energy level is P, that is 2p. So the fifth electron moves to 2p. The 1 electron of P now goes to px orbital. It is unpaired. For elements from carbon to neon, that is in the second period. Next element is carbon. It has 6 electrons. The subshell electron configuration is 1s2, 2s2, 2p2. As per Pauli exclusion principle, there can be a maximum of 2 electrons in an orbital. Yes, subshell has only 1 orbital each, but p subshell has 3 orbitals. As per Hund's rule, pairing cannot start until all the 3 orbitals of the p subshell is filled with 1 electron each. So the 6th electron moves to 2py. The 2 electrons in the 2 separate orbitals of p subshell are in same direction. Next is nitrogen. Atomic number is 7. It has 1 electron more than that of carbon, and the additional electron moves to 2pz. This we have already seen in the previous video. Now when we come to oxygen, atomic number is 8. There are 4 electrons in p subshell. The 3 orbitals of the p subshell are singly occupied already. So this additional electron starts pairing up in 2px. It becomes 2px2. This is in perfect agreement with Hund's rule. For fluorine, atomic number increases by 1 and the additional electron moves to 2py, making it paired. There is only one unpaired electron. When we come to neon, the atomic number is 10. Here, all the three orbitals of the p subshells are paired and fully filled. Neon is the last element in period 2, that is second period. It belongs to group 18. It is noble gas. The first element in 18th group is helium. It belongs to first period. In the third period, there are 8 elements and the azimuthal quantum number 4, principal quantum number 3 is equal to 3. That is, it has 3 subshells S, P and D. But the d orbitals do not get filled up in period 3. It starts getting filled up only with elements in fourth period after filling 4s orbital. This is as per aufbau principle. I have given the sequence of these various orbitals with increasing energy level in the coming slide. Okay, let us continue. I have selected a few elements at random here only to show an alternate method of representing the electron configuration at orbital level without showing orbital picture diagram. That is, instead of showing orbital picture diagram, the orbital distribution can be shown as is shown here. And this can be further simplified. Let us see how it is done. Argon atomic number is 18. It is the third element in 18th group. It comes under third period. If you remember aufbau principle, pauli exclusion principle and Hund's rule and apply it properly and correctly, then you can easily write the orbital electron configuration of argon or any other element as is shown here in this order. Here you find that the last electron goes to 3pz and all the orbitals have paired electrons. If you have any doubt, first arrange the electrons in K, L, M and N shells using the formula 2 into n square, where n is the principal quantum number. For M shell, the principal quantum number is 3. So the maximum number of electrons it can accommodate is 2 into 3 square, which is equal to 18. But for argon, there are only maximum of 18 electrons. So the electron configuration becomes 288. All these things you have learned in your smaller classes. I was only helping to recall these things. 288 makes it 18. So first you can write this and then distribute it in this manner. But I would recommend you to remember the aufbau principle and then follow it in that method. That will be easier and faster. But for elements with higher atomic number, this method becomes very, very tedious. So another easy method also can be applied. For example, in the case of argon, it is the third element in group 18, that is noble gas. The noble gas preceding argon in group 18 is neon with atomic number equal to 10. This portion of the orbital electron configuration represents that for neon. So, electron configuration of argon can be written using the symbol for neon within square brackets. Neon 10, then followed by 3s2, 3px2, 3py2 and 3pz2. So while applying this method, we have to use the symbol for the noble gas in the preceding period within square bracket, followed by the rest of the distribution. This method is very, very useful for heavy atoms. Say for example, atomic number of potassium is 19. It has one electron more than that of argon. It belongs to fourth period. As per aufbau principle, the next higher energy level is 4s. 3d orbital can get filled up only after filling 4s. So the additional electron in potassium fills up 4s. Instead of showing the entire orbital distribution of the electrons, it can be shown as is shown here by using the symbol of argon. Argon 18 within square brackets and then 4s1. Calcium and potassium differ in one electron. That electron goes to 4s and it gets paired. For scandium, the atomic number is 21. The next higher energy level orbital is 3d. So that electron moves to 3d. So 3d14s2. You can just go through the increasing order of energy levels for the orbitals which I have given here. So when we write the electron distribution, remember electron distribution, it will be argon 18 within square bracket followed by 4s2 3d1. This is distribution. But when we write the configuration, it should be 3d1 4s2. Why is it done so? This is followed in order to allow all the orbitals of the same principal quantum number to be in sequence. So remember that principle. The next element is krypton. It has atomic number equal to 36. It is the fourth element in group 18 and is a noble gas. 3d is completely filled. The remaining electrons fill 4px, 4py and 4pz. They are all paired. I hope it is clear. Rubidium belongs to fifth period. It has one electron more than that of krypton. The next higher energy level after 4p is 5s. Only after that 4d can fill. The fourth period noble gas is krypton. So for writing the electron configuration of rubidium in a simple way, we use krypton 36 within square bracket and then 5s1. I hope it is quite clear. You can practice this for more elements and gain confidence. In the next video, we will see the electron configuration of a few transition elements with exceptional electron configuration and its explanation. I hope the video was of great use to you. If you think the video was useful, do like the video, share the video, and also give me your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do support me by your subscription and also press the bell button in order to get notified as soon as new videos are posted. Thank you very much. Bye for the present. Take care.